Hi, in this lesson, we're going to talk about probability. The probability is the chance that something will happen, how likely that event will happen, and then the sample space is the set of all possible outcomes of an experiment. Here's some vocabulary about single event probability. So, an experiment is a situation involving chance or probability that leads to outcomes. A fair experiment is an experiment where the odds are evenly distributed. An event is the result of one or more outcomes of an experiment. An outcome is the result of a single trial of an experiment. Probability is the chance or measure of how likely an event will occur in a random experiment. This is indicated on a 0 to 1 scale or in percentages from 0 to 100%. 0 would be impossible. Half would be even chance. So you guys probably heard like 50-50 chance a lot. That's 50%, 50%. And then 1 would be certain. And then the probability of an event happening would be the number of successful outcomes divided by the number of possible outcomes. And we'll see some examples in a bit. But first, let's talk a little bit about sample space. It is all the possible outcomes of that experiment. So if your experiment is flipping a coin, then you could either get heads or tails. That would be the sample space. So the total outcomes for flipping a just single coin would be 2. You could either get heads or tails. If you roll a single die, you'll get a 1, a 2, a 3, a 4, a 5, or a 6. So this will have 6 total outcomes. If you spin this spinner here, notice that the area of each color is the same. And you could get either blue, red, green, or yellow. So there are 4 possible outcomes. If your experiment is picking a card randomly from a deck of cards, here's an example of a standard deck of cards. Um, Notice that there are 4 suits. You have clubs, you have spades, you have diamonds, and you have hearts. And for each one of these suits, there are 13 different cards. There's an ace, there's the numbers 2 to 10, there's the jack, a queen, and a king for each one. So there's 13 for each suit. So that's a total of 52 cards, 52 different cards. This is just a sample space. Now we'll get into probability. You need the sample space. For example, what is the probability of landing on blue? Well, if I land on blue, that the probability of landing on blue is 1 because there's only one blue section out of 4 because there's a total of 4 sections. Similarly, the probability of landing on red, there's only one red section out of a total of 4 sections. So it's also 1 out of 4. Sometimes you would see decimals, so just be comfortable with converting that into a decimal. That's 0.25 or 25%. Okay. You're gonna have, if you have problems about cards, what's the probability of pulling a 4 from a deck of cards? Well, there are 4 fours in the entire deck. So 4 out of 52. You do need to simplify these all the way. So 4 out of 52 simplifies to 1 out of 13. And if you have to convert that into a decimal, it's going to be 0.08. We usually going to round to 2 decimal places. The probability of pulling a heart. Well, all these cards down here are hearts. That's 13 out of the 52. And then simplifies to 1 out of 4, which is 0.25. Okay, independent events. Independent events, an event where the current outcome would not affect the outcome of the future outcomes. So in these, you're going to have two or more events going on. And then to find the probability, you're going to multiply each independent probability of each event occurring. So for example, first example here, the probability of red and blue. So this is for spinner. What's the probability of spinning red and then spinning blue? Well, we know that for red is 1 out of 4. And for blue is also 1 out of 4. So to get the probability, you're going to multiply these fractions. It's 1 out of 16. And convert that to decimal, 0.06. Okay. Second example, what's the probability of flipping a coin and getting heads, and then rolling a die and getting a 4? So the probability of getting heads, that's 1 out of 2. And then the probability of rolling a 4, that's 1 out of 6. You multiply these to get the probability 1 out of 12. Convert that to a decimal, that's 0.08. Okay. So if it's independent events, you just need to multiply the probability of each event. Another example of an independent event, what's the probability of getting 3 heads in a row? Well, these events are independent. So the first probability of getting heads the first time is 1 out of 2. The second time is also 1 out of 2. And the third time is also 1 out of 2. These are independent events. But now the probability of getting 3 in a row, then you have to multiply these. So that's going to be 1 out of 8. That's 0.125. Another example. So what is the probability of each number on the die occurring? So remember there's 6 numbers on the die, so that's 1 out of 6. Here's the example down here. What is the probability that you roll a 4 and then a 6? So in shorthand, what's the probability of getting a 4 and then the probability of getting 6? Well, the probability of getting a 4 is 1 out of 6. And then the probability of getting a 6 is also 1 out of 6. So if I multiply these independent events, you get 1 out of 36. That is 0.03. It's a very low probability. All right, more examples. Probability of landing on red and then blue. So red is 1 out of 4. Blue is 1 out of 4. So you multiply these independent events and you get 1 out of 16. Probability of pulling a 10 and then an odd number. So to pull a 10, there are right here, there's 4 10s out of total of 52. and then an odd number. So odd numbers, there's threes, fives, sevens, and nines. Those are the odd numbers. So there's four of each. So 4, 8, 12, 16. So that's 16 odd numbers out of 52. So you're going to multiply this. So 4 times 16, 64. And then 52 times 52 is 2,704. Okay. So that's a big fraction. You're going to eventually simplify this to 4 out of 169. Okay, that one's a little bit more complicated. Last example here. A different color. Rolling a die, rolling a 6, and then rolling a 6 again. So probability of rolling a 6, then the probability of rolling another 6. So that's 1 out of 6 times 1 out of 6, which is 1 out of 36. Dependent events. This is an event that is affected by the previous event because the sample space changed after the first outcome. So some examples are going to be from picking a card from a deck without replacing it. So if you do not replace the card, it changes the sample space. Or choosing an M&M from a jar and eating it right afterwards. When you pick another M&M, your sample space changes because you just ate one of them. So let's look at these examples here. Find the probability by multiplying each independent probability of each event occurring. So the probability of picking a queen, not replacing it, and then picking another queen. So here there's 4 queens in a deck. So when you pick the first queen, it's 4 out of 52. Okay. So let's say you pick this queen and you do not replace it. So when you pick the second queen, that card is not there anymore. So there are not 4 queens left, there are only 3 queens left. And there are not 52 cards, there are only 51 cards. So this is an example of dependent events where the sample space changes. So now you multiply these fractions. 3 times 4 is 12, and then 52 times 51, that's 2,652. And then that simplifies to, looks like you could divide the top and bottom by 4. I think divide the top and bottom by 6. Yeah, no, I'm sorry, by 12. You could divide the top and bottom by 12, so this turns into 1 out of 221. That's the most simplified answer. Okay. Another example. This is the M&M example. If you're gonna find a probability of picking a red M&M, you eat it. Then you pick a blue M&M, you eat that one, and then you pick a yellow one. Okay. So for red, so there's 4 reds, 2 greens, 3 yellows, 2 browns, 3 blues for a total of 14. So for red, it's 4 out of 14. Okay. Then you ate the red one. So now there's only 3 reds left. So I'm gonna pick a different color for this probability. So there's 3 reds left. So now there's only 13 M&Ms. So the probability of getting blue is 3 out of 13. Okay. And then after you eat the blue M&M, you're left with 2. And now instead of having 13, there's 12. So the probability of picking a yellow M&M is going to be 3 out of 12. And then to find the total probability, you multiply these fractions. So 4 times 3 times 3, that's 36. 14 times 13 times 12, that's 2,184. And that simplifies to 3 out of 182. Okay, so in these examples, the sample space changed. All right, another example. An animal cage is holding 6 black cats and 9 white cats. None of them want to be in there. The cage door opens slightly and 2 cats escaped. What's the probability that the escaping cats are both black? So the probability of the first cat being black, it's going to be 6 out of, and then the total is 15, because 6 plus 9 is 15. So if the first cat is black, then the probability of the second cat being black, the 6 turns into 5, because there's only 5 black cats, and the 15 turns into 14 because the total dropped. So multiply these fractions. 6 times 5 is 30, and 15 times 14 is 210. That simplifies to 1 out of 7. The probability that the escaping cats are both white. Okay, we start with 9 out of the 15 cats are white. That's for the first cat. And then for the second cat, it drops to 8 over 14. So 9 times 8 is 72. And then 15 times 14, that's 210. And then you're going to have to simplify that fraction to 12 over 35. Okay. And then these are the first 2 problems in the homework. I'll just work these out with you. So we're going to find the probability. So we have a bag that contains 8 red marbles, 3 blue marbles. You randomly pick a marble and then pick a second marble without returning the marbles to the bag. So without returning. What's the probability that both marbles are red? Okay, so there's 8 red and 3 blue, so it's a total of 11. And then we want both to be red. So probability of red and probability of red. So for the first red one, it's 8 out of 11. You do not replace it, so it drops to 7 out of 10. So 7 times 6, that's 56. 10 times 11, that's 110. This simplifies to 28 out of 55. And then the decimal would be about 0.51%, 0.51. Okay. Number 2, a cooler contains 13 bottles of sports drink, 4 lemon lime, 4 orange, 5 fruit punch. You randomly grab a bottle, then you return the bottle to the cooler, mix up the bottles, and randomly select another bottle. Both times you get lemon lime. First, let's get the total. Oh, it's already given. It's 13. Okay, both times are lemon lime. So how many lemon limes do we have? 4 are lemon lime. So probability of lemon lime, replace it, right? Because you return it, then the probability of lemon lime again. So 4 out of 13 times 4 out of 13 because it was replaced. That's going to be equal to 16 over 169. And if you want to turn that to a decimal, that's going to be 0.09. So number 1 is an example of a dependent probability, and number 2 is an example of an independent probability. That's it.